All right, this just kind of sums up the exponential growth formula. It can be modeled by y equals c e to the kt, where y represents the population after time t, c is the initial value of y, or the initial population, and k is a constant of proportionality. If your constant of proportionality is greater than 0, then exponential growth will occur, and if your constant is less than 0, then exponential decay will occur, so your population will be decreasing. Suppose that 10 grams of the plutonium isotope Pu-239 were released in the Chernobyl nuclear accident. How long will it take for 10 grams to decay into 1 gram? And we're also given that the half-life of plutonium-239 is 24,360 years. All right, so our formula is y equals c e to the kt. Unless they tell you that your constant of proportionality is, unless they specifically tell you what the constant of proportionality is, k is the first thing that you're going to have to find. So we're going to use this half-life part. We know that the half-life is 24,360 years. So c is the amount that we start with. I'm just going to start with any amount. I'm going to start with 1 gram because I think that's the easiest. If you start with 1 gram, then the amount after 24,360 years is going to be half of that, or a half a gram. So the formula is your ending amount, which is 1/2, equals the beginning amount times e to the k, that's what we're looking for, and then the time is 24,360. All right, so now our job is to solve for k. You can use your calculator, and you can type this directly into your calculator, or we could take the natural log of both sides. And if you take the natural log of both sides, then you get the natural log of 1/2 equals, and the natural log of e to a power is just that power. So therefore k equals the natural log of 1/2 divided by 24,360. And the only reason I did this by hand is that I think some people can do that by hand faster than they can find the buttons on their calculator. But just for kicks, let's solve it using the calculator. Okay, so solve under F2. And I'm trying to solve the equation 1/2 equals E, and E is diamond X. So e to the 24,360 x. And remember, you have to do comma x and close your parenthesis. And the calculator gives you negative natural log of 2 over 24,360. That really is what we got, because the natural log of 1/2 is the same thing as the natural log of 2 to the -1 power, and the negative can come down in front. So either way, we get the same thing. And it may be helpful to use your calculator, because you do need to use, we need this exact answer. So what I'm going to do is I'm going to store this answer in a different variable. So I am going to go back up and highlight that answer, although I have to erase the x equals part. Okay, so I'm going to take that answer and I'm going to store it by doing the STO button, and I'm going to store it in Y. You could use K if you wanted, but you'd have to hit the alpha key, and I'm lazy. I don't want to use the K key. All right, so I'm going to store it in Y. Whatever you do, don't store it in X, because if you store something in X, as soon as you go to Y equals, that's going to screw things up. Okay, so now I've got that stored in my calculator. Okay, let's go back to the actual problem. So now I've found K, and actually it would also be helpful if, when you find K, if you'd give me a decimal approximation for it, just so I know that you're on the right track. So I'm going to take that answer and do diamond, enter. So negative 2.845 times 10 to the -5. Okay, so now we can actually figure out how long it's going to take for 10 grams to decay into 1 gram. So the ending amount is 1, the beginning amount is 10, e to the, and I'm just going to write k. I've already identified that k is this number right here, so it's okay to write k there, and then t. And I'm going to go back to my calculator and I'm going to solve this problem. And I'm going to solve this problem for t. So solve 1 equals 10 e to the k, and I personally stored k into y. And then I like to use x because I may also have something else stored in t, so I'm going to use x. And close my parenthesis, and I'm solving for x. Okay, I'm going to get an error here, and I did this on purpose. I'm not here to defend myself. Okay, I should get a value of x right here, but it's giving me a value of x, or it's giving me another equation with the y. And that's because of this calculator does not understand implied multiplication. This y times x, those are two different variables, so you have to put the time sign between the two of them. Otherwise, it's viewing yx as a separate variable. So make sure you put the time sign between y and x. Okay, hit enter and you get this value of x, which to me, that means absolutely nothing. And if you hit diamond enter, then you'll get a decimal approximation. So remember that you always have to round to 3 decimal places, no matter what, unless they specifically ask you not to. So therefore, it takes 80,922 gears, 0.168. And one other thing that I want to point out is that in my calculator, I was letting k be y, and in my calculator, I was letting t be x. If you're using t's on your paper, make sure that your final answer is t equals and not x equals. They get kind of cranky when they're grading your AP exam if you've got all these different variables and all of a sudden your answer is randomly an x. And that's an easy mistake to make, but try and really pay attention to what variables you're using. Okay, number 5 is kind of cool because it's a little bit of a twist on this. Atmospheric pressure, P, decreases exponentially with increasing altitude, x. So let's first start. This is kind of, most of the examples that you're going to do deal with time, but time is not part of this problem. And most of the ones that deal with time, well, if it does deal with time, then you know that time is your independent variable. And you're using the formula y equals c e to the kt. All right, however, what we're dealing with here are pressure and altitude. So the first thing we need to determine is which one's the independent and which one is the dependent. Does the pressure depend upon the altitude, or does the altitude depend upon the pressure? The pressure depends upon the altitude because it says that the pressure decreases exponentially with increasing altitude. All right, so pressure is your dependent variable. So if you want to rewrite your equation in terms of P and X, it would be P equals C e to the kx. And now we've got the same variables that are going on. Okay, so the pressure is 760 millimeters of mercury at sea level when x is 0, and 672.71 millimeters of mercury at an altitude of 1,000 meters. Find the pressure at an altitude of 3,000 meters. Well, that's asking for us to basically find x, the final problem, but we don't know what k is. So the first step is to solve for k. All right, so P is the ending pressure and C is the beginning pressure. So I'm going to think of 760 as the beginning pressure at sea level, and then the ending pressure is 672.71 e to the k. And like on the last problem, it told us that the half-life was 24,000 something years, I think. Yeah, 24,360 years. So over that period of 24,360 years, the amount of plutonium decreased by half. Well, here the pressure goes from 760 to 672.71 over a span of 1,000 meters. So we're going to put in the 1,000 for the x, like that. Okay, let's go to our calculator and let's solve for this. Okay, and I have my calculator set where if I use a decimal in the problem, I get a decimal answer, but you may have gotten the exact answer. It doesn't matter which one you use. So K is approximately negative 1.220 times 10 to the negative 4. I'm going to jot that down on my paper real quick. Okay, and I like for you to do this because I can give you partial credit along the way if you mess up somewhere else. All right, now the next thing I need to do is store that value. So I'm just going to go up and I'm going to capture the x equals, but I have to erase the x equals. And you can store it in whatever variable you want as long as you're not using x. I'm going to use y. Okay, so I've got it stored there. Okay, so then my last step is to find the pressure at an altitude of 3,000 meters. So that would be looking for the ending pressure. So that's my P. C was the beginning pressure at sea level is 760. E to the K. So my equation is actually 760 E to the K times 3,000. There we go. So 527.056. And your units are millimeters of mercury. Okay, so hopefully you remember problems 4 and 5 from pre-cal last year. Just make sure you find that value of K first, and then you can answer the question.